Section 5.2, day 2. This is going to be exactly the same as day 1. It's just the problems are going to be larger. So that's going to make them a little more challenging. All right, the first step is to rewrite this system of linear equations as an augmented matrix. So that would look like this. And we're going to do the exact same thing again that we did the last time when we're looking at smaller systems of linear equations. So our first move, even though we're able to interchange two rows, we're going to keep the first move the same. We're going to be very consistent in this algorithmic process, which is Gauss-Jordan elimination method. So what we're going to do, with that being said, is we're going to focus on our 1, 1 entry, which is right here, upper left corner, and we're going to make that a 1. And we're going to do that by multiplying row 1, the entire row 1, by the reciprocal of that number. Again, after I have it on my paper, I'm going to go to my calculator and enter in the information so I can perform row operations with technology, making it much easier. So what I'm going to do is go to second matrix, which is right here, second x inverse, that's matrix. Go to edit, and then we're going to enter in a 3-row by 4-column matrix. And then let's put our numbers in. So 2, 1, negative 2, 4, 1, 3, negative 1, negative 3, 3, 4, negative 1, and 7. Once you have those numbers locked in, you're going to hit second and then mode to quit out of that. All right, so let's go ahead and perform this first row operation using our calculator. So 1/2 R1, 1/2 R1. All right, so here's what that would look like. We're going to do second matrix, go to your math tab, go up until you see times row, hit enter, and then the multiplier is 1/2. So enter in 1/2, that's your first parameter. The matrix you're working on is the second parameter, that's matrix A. And then you're going to put a comma. And then the third and final parameter in this times row function is the row that's being multiplied by 1, which in this case is row 1. So do that, hit enter. And then I always hit math, enter, enter, to convert my entries into fractions. And then what do we always do at this point? We always do store, right here, and then matrix A. So second x inverse, matrix A, and enter. Now it's locked in. Okay, so I'm going to take, again, this information on my calculator screen, write it down on your paper. You will be required to show work for these problems on the next test. You're going to have to send me your work via PDF. We'll talk more about that as we get closer to your fourth and final test. Okay. Anyway, moving on here, what we now have is a 1 in the 1, 1 entry. That's exactly what we want to do. Now we have to zero out everything below this 1. So after we've created our what's called our leading 1, every other entry in that column, here and here, in this case, must become a 0. So to handle that, we're going to do the following. Write down the row that's going to be changing, row 2, minus the opposite of whatever this number is. In this case, it's -1, times the row in which we just created a pivot entry. We're going to, below this, write down another row operation. So let's look at row 3. We need to change this 3 in row 3 to a 0. So to accomplish that goal, we write down the row that's changing. This is the appropriate notation. -3. Why? Because -3 is the opposite of 3. And then times row 1, because row 1 contains our pivot entry. Okay, we go back to our calculator, and we're going to perform our first row operation, which is going to be this one. All right, so using our calculator, we would do that by hitting second matrix, going over to the math tab, go up arrow until you get to times row plus, hit enter. Our multiplier is -1. The matrix we're working on is matrix A. The row that's being multiplied by -1 is the row in which we just created a 1, which is row 1. The final parameter, in this case we have 4 parameters, is the row that's changing. Your fourth and final parameter here is going to be the row that's changing. In this case, that's row number 2. Let's lock it up, hit enter, and note you have a 0 now where you wanted a 0 in the 2-1 entry. Before you do anything else, you do store, second X inverse for matrix, matrix A. You do this after every single row operation. All right, the next row operation is this one. So let's go ahead and do that as well. Second matrix, go to math, times row plus. In this case, our multiplier is -3. So we'll put a -3 in there first. The second parameter is the matrix. The third parameter is the row that's being multiplied by -3, which is row 1. And the row that's changing now is row 3. So you have that locked in. We hit enter. And again, you check every time. There should be a 0 here, and there is, so we're in good shape. And then again, before you do anything else, you always hit what? Store, and then the matrix you're working on, which we're working on matrix A. Hit enter, now it's locked in. So now I'm gonna put this information on my paper. After I've entered the information down on my paper into my new matrix, I now look at the 2-2 entry, which is the second row, second column, my 2-2 entry. I need this to become a 1. So all you have to do to make 5 halves specifically becoming 1 is to write down the reciprocal of 5 halves, which is 2/5, and multiply it by the row in which it's located, which is row 2. So I'll now perform this row operation using my graphing calculator. So to perform the row operation, 2/5 R2, using my graphing calculator, I'm going to do what? I'm going to do it a second matrix, math, times row, and then I'm going to put in the multiplier, which is 2 divided by 5, 2/5, put a comma, second matrix, matrix we're working on is matrix A, put a comma, third parameter is the row that's being multiplied by 2/5, which of course is row 2. Lock that in. We now have a 1 right here. That's what we want. And so now we do what? We always do store, and then second X inverse for the matrix menu, matrix A, lock it in. I'm now gonna write this on my paper. All right, so now we have our 1 established here in our 2-2 entry. We now need to 0 out every other entry. So we need to make this 1/2 become a 0 and the 5 halves become a 0. To make this 1/2 become a 0, we're basically going to do exactly the same thing as we did previously. So what do I mean by that? Well, you're always going to put down, let me show you both things at once. You're going to put down the row that needs to change first. Row 1 needs to change. Then you're going to not multiply. Then you're going to write down the opposite of the number that needs to become a 0. In this case, the opposite of this number is -1/2. The final thing is going to be to multiply it by the row in which we just created a 1, which is row 2. All right, it's very similar. It's a 2-step algorithmic process, essentially, to complete Gauss-Jordan elimination. All right, we also need to 0 out this 5 halves. So to do that, we write down the row that contains the 5 halves, row 3. Then we put down the opposite of 5 halves, which is -5 halves, times the row that contains this 1. All right, so I'll now use my calculator to perform both these row operations.